Hello everybody. My name is Miles Abrams. You're in the drone presentation. If this is not your presentation, please take another seat. What I'll be doing today is talking about drones. I think we can do this in an open forum, but I do imagine that any question that you have, I'll come up with an answer with sometime during the presentation, so it's up to you if you want to ask or hold your question to the end. I've got 50 minutes to do this. I shouldn't have any trouble getting it done in the required time. And I think without further ado, we'll go ahead and begin.
There's always been that, okay, so what are you going to do next after Drone 100? Can you do something more? The difference between 100 and 500 is mind-blowing.
We have changed the whole thinking from many individual drones towards one single fleet of drones.
The drone itself is a completely new drone. This is the Intel Shooting Star. It's made to be lightweight. It has a propeller cage so that we can ensure that everything is done safely and securely.
A fleet of these drones actually needs to have special permission. So we had to work with the FAA to show that we can operate this in a safe way. And it has been designed where two people can actually operate it by themselves. Why two people? Because you need one person for backup.
All this drone can do is light up the sky. But this is something it can do really, really well.
It takes the whole concept of a light show into a whole new domain. It drives human imagination. It creates an expression of art.
This is something that we never could have done last year. It's been an amazing experience just to see the technology develop so quickly.
So quick about me. I do this professionally. I'm a licensed remote pilot and also a private pilot. I'm a certified thermographer, which means I can do stuff in infrared. 20 years in information systems, so I feel a connection to this group today. SAP, Bertelsmann, MGM, IBM. I actually, a long time ago, I was in the circus. I was a lighting designer, and I was with Radio Shack when I was in college. I founded Eskin Drones to deliver aerial services to the Northeast, and the only way to do great work is to love what you do. So, what are we talking about here? The history of remote aviation in the United States. If you go back far enough, it starts with the Chinese. They used a kite to measure the size of enemy defenses. The line of a kite, Pythagorean theorem, they figured out the dimension of the enemy fortifications. Spanish-American War, another highlight. We used hot air balloons and photographed the enemy from altitude. Then, long about the same time as the quad configuration, that's the quadcopter, what people normally would associate with drones. The same year that was proposed, we had the first U.S. aircraft registered in the United States. The predecessor to the FAA established a registration process. First registered pilot came along a few years later. Lithium polymer batteries, a whole bunch of other things happened. I'm not pretend to say I'm covering all of aviation in the United States, please. But lithium polymer batteries were another major innovation relative to the remote aviation as we know it today. Brushless motors and electronic speed controls. I'll go into that when I talk about technical stuff, but those were significant innovations. In fact, brushless motors actually were used extensively in computers and still are today. Let's see, flight control software. This was the separation. If anyone here do any radio control stuff? Radio? Okay, any pilots? Anyone with a pilot's license? Okay. I've got a couple of jokes for just for you. So the flight control software is simply the separation between actually controlling the control surfaces with stick and rudder and having a brain in the drone, in the aircraft, that made its own decisions relative to the inputs that you provided. Let's see. Next thing to come along that I think was important is the FAA Modernization and Reform Act. Prior to this, it was the Wild West. You could do anything anywhere with a remote aircraft, and then Congress said, we better do something about this, and directed the FAA to develop a program to regulate unmanned aircraft. The first thing to come out of that was something called the 333 exemption, whereby you could petition the FAA, and if you could convince them that you could operate safely, they would give you permission to operate a drone. Movie sets were a pretty common application for this kind of exemption. Just as a key point of reference, in 2014 there were 210,000 aircraft registered in the United States. By 2020 we estimate to have 7 million drones registered in the United States. Wow, standing room only. I am so flattered. I have no way to get you guys chairs. I've got to stay here, but if there's some others, please feel free to grab it. Make as much noise as you need in the background to get everybody comfortable. Thank you. Let's see. 2015, we've got 590,000 Part 61 pilots. Those are private pilots, that sort of thing. 45,000 drones that were registered in just 3 days, the 3 days that the FAA established the National Registration Database for drones. So if you look at this guy, it's got a little number here labeled FAA. This is my official registration number for this drone for the FAA. I've got a different number on the bottom of this one because this one has a separate registration. If you are a commercial operator, every drone must be registered. If you're a recreational drone operator, you only need one number. Thank you for the question. Yeah, that's exactly right. If you don't do it for money, you're doing it correctly. Did you know that there's a court case happening now that's maybe overturning the recreational side of the drone registry?
Yeah, part of the because the Academy Mile Aeronautics was saying, we have all the registration information for people, why can't they just use their AMA number?
Well, the AMA didn't contest it. This guy, John Taylor, did. We'll talk about it later. It's probably not, but it's really interesting how it's evolving. Let's see. So the exemption process, the Modernization Reform Act, was a predecessor to what changed in 2016. In 2016, the FAA came out with what we call 107, which allows people to get a remote pilot's license. That's what I've got, and that allows commercial operation of an unmanned aircraft, but I don't need to go through an extensive process of proving every single thing that I do, everything I touch, all the equipment that I have, all the procedures that I have are uniquely designed for me, and I deserve a special exemption. I'm going to abide by all the rules that are already in place. Sir?
Now that's basically just like having ground school certification for a regular pilot.
It's not. There are no practical test standards. That's correct. It's just knowledge.
I'm saying you just basically you're taking the same. If you already have a license for the ground school certification.
If you already have a pilot's license for manned aircraft, you don't need to take the test. You just need to take a course, which is how I did it. So if you have a current pilot, it has to be current. It can't be expired. If you have a current private pilot's license, commercial, whatever, you can get your remote pilot's license simply by taking a class online. Let's see. So in 2017, we're expecting to have 600,000 remote pilots registered, which means we're going to already exceed in just a couple of years the number of pilots registered to fly manned aircraft. I think that's rather impressive. And that kind of brings us up to date. The 7 million registered drones, again, there's a very interesting court case right now which may completely excise a large portion of this database, but that's not really outside this conversation. So that's the timeline of remote aviation as I see it. Definition of a drone. The shortest definition I got out of Wikipedia, it's an aircraft without a human pilot aboard. Slightly longer definition comes from Chris Anderson. Chris Anderson's the editor of Wired magazine and is an integral part of what we consider to be remote aviation today on the hobby side. He was one of the very first people to understand and enable flight control. He took a couple of toys that he had given, a couple of different toys that he had given his kid, and tied them together in a way that hadn't been done before, and essentially made a hobby flight controller. So what he says is it refers to aircraft that have the capability of autonomous flight, which means they can follow a mission from point to point. I think it kind of leaves some parts out of what we know remote aviation to be, but it's an interesting definition nonetheless. And the longest definition comes from the government. An unmanned aircraft system, UAS, sometimes called a drone, is an aircraft without a human pilot aboard. Instead, it's controlled from the operator on the ground. When you fly a drone in the United States, it's your responsibility to understand and abide by the rules. Wow. Thank you, everybody, for coming. This is great. Okay, so the anatomy of a drone. What I've got here is is an old drone. It's a couple of years old, which makes it ancient in drone years. And I'm going to go through the different parts of it for you right now. So you've got the body, and carbon fiber is one of the key enablers of drone flying because of the strength to weight ratio. And this one has, is made of carbon fiber. It's also made of styrofoam. It's molded styrofoam. It weighs nothing. You are, by the way, after this, you're welcome to come up and touch anything you want on the table. The radio is actually how we have telemetry back and forth to our transmitter. It gives the signals back and forth. There's also a radio in many of the drones today for cameras, for video signal. But that's, the one I mean in this context is the radio to control the drone. Sir?
Are the radios, are they all fixed range?
No, they're not.
It's like your Wi-Fi. It's just going to be overloaded one day with people in the same range.
So it's the, oh, you mean the bandwidth? Yes, in fact, we not only is it limited in that way, we occupy the same bandwidth that Wi-Fi does. We're in the 2.4 and 5.8 range. What we do is we have digital signals. The transmitters are surprisingly sophisticated. These are digital signals with step frequencies, and the folks in the ham radio would be able to explain this a little bit better than I do in terms of exactly how it works. But there's frequency hopping. There's a number of things to make sure that we don't have interference with other people in the field. Go back far enough, it was all done with crystals. Everybody had their own crystal, and you signed one out before you went flying. We do it a little differently today for the radio transmitters. We don't worry very much about who else is on the field in terms of radio transmission because we use equipment that has hundreds and hundreds and hundreds of potential frequencies.
One question we always get with our monitor as far as you can see.
Yeah.
Remember, you're dealing with line of sight when you're in the air, the company, right?
Yeah. We do talk about going beyond visual line of sight. It is not allowed under FAA rules, and it's not allowed under AMA rules either. You must maintain sight of the aircraft. That's one of the things, incidentally, that exemptions are still very much appropriate for. For example, one of the railroad companies has an exemption to fly drones for a rail inspection out of line of sight of the pilot. Kind of makes sense. It's not going to be financially practical otherwise, and those are pretty sparsely populated areas that they're talking about inspecting. So that, oh, whoops, I forgot the flight controller. The flight controller, I'm going to talk about this in detail, but the flight controller is essentially the brains. It has accelerometers, gyroscopes, and inputs for other sensors. It also has the loaded software to direct the motors, to direct the rest of the drone as to what to do. And it's directing traffic to, for example, the electronic speed controllers. Best analogy I can give here for ESCs is everyone here knows old school stereos where you had a preamp and amplifier in your speaker. Think of the flight controller as the preamp, the speed controller as the amplifier, and the motor propeller combination as the speaker. This is what's taking that heavy duty amperage from the battery and the input signal from the flight controller and directing that flow of energy to the motors. The motors, of course, are on the ends of the body, and they are what spin the propellers. The battery is going to be one of the biggest parts of it, certainly one of the heaviest. This is a relatively small battery. They can come much bigger. To give you an idea of, let's talk about LiPo batteries for a second. So lithium polymer batteries, chemistry, this is one of the new ways that batteries are being made. Everyone probably knows about the Samsung phones and the batteries there. This is the same stuff. So we need to be careful with these batteries, and when you get into the hobby or get into the profession, battery management and safe use of batteries is one of the things we talk about. You don't store them fully charged. You also don't store them fully discharged. You store them at 50%. You take care of your batteries. If you're not going to use them for a few months, you must discharge them down to a storage level, or they do risk the possibility of fire. There's a lot of energy stored in these things. The combination of the 4 speed controllers, the one battery, to give you a sense of how much power there is here, each of the speed controllers, well, so this battery is 11.1 volts. Generally, when you're racing, you're using a more powerful battery at 14.4 volts. These are 3.7 volt cells. That's why the math works that way. The electronic speed controls are capable of 30 amps each. So that's a total of 120 amps on 14.4 volts. What does that work out to? About 1,200 watts? I know that it's the same amount of amperage I use to raise the anchor on a 40-foot cabin cruiser.
How long will it run when you're pulling that amp?
Probably 5 to 10 minutes, not very long at all.
But you're not always running.
No, you're not. Except when you're racing. Yes. If you're serious, you'll actually build yourself a little battery box out of cinder blocks or something just for that reason, because they are a legitimate fire hazard. There's no question about it. Okay. Sir?
The biggest problem with lithium batteries is charging them or discharging them very quick, and that's when they become a real fire hazard. So fast charge and discharge really heats them up.
Yeah. That's actually the battery industry is, the race within the battery industry is to be able to discharge quickly without a fire hazard, to dump energy fast.
You also need to balance charging. You need to make sure the cells are the same.
Absolutely.
Plug a charger into it, it's going to make overcharge.
No, you need a balanced charger for sure. Okay, so one of the things that's fun about this, and in fact the birth of the sort of the hobbyist into the commercial remote industry as opposed to defense down, you can sort of see it coming from two directions. These big, basically people took manned jets and made them unmanned. We're taking, toys and turning them into commercially viable products, commercially viable tools, excuse me. So one of the things that I find interesting about this is what you've got here is this motor has firmware. The battery, not this one, but the more sophisticated batteries are actually intelligent. They will discharge themselves if you don't use them. They have firmware. The radios, the transmitters have firmware. The flight controllers have firmware. The point I'm making is that there's anywhere from 7 or more computers that are on this thing at any one time. I like to say, the joke about helicopters not being an aircraft, it's a bunch of parts flying in formation. A drone is not an aircraft, it's a bunch of computers flying in formation. So what we can do with that is, let me show you. I want to go into a tool that we use in the drone racing community called Betaflight. And there's a bunch of different free. So what we've done is, there are different flight control packages. There's Ardusoft. There's They come from different places. The original, for example, the original flight controller sensor inputs. This actually came from the robotics world. When the guys and gals doing robotics were first trying to look for compact package sensors, they took the Nintendo Wii controller and hacked it. So you will go around now and you will find software for using these sensor inputs, and it's got Wii in the name, so you can kind of get the genealogy of these freeware packages based on what sensors they were using to get their data. So this one's called Betaflight. This came from something called CleanFlight, and it's what people generally use today. And I'm sorry, my controller is so old it's not using that anymore. I've got to go to my old software. Sorry. There. So this is the flight controller. This little board here is my flight controller. On here are 3 gyroscopes and 3 accelerometers. In addition, I've got a number of inputs that I'll get into in a second. But what I want everyone to understand is that the entire telemetry, everything that the drone needs to know, where it is where it's positioned in space, where it's going, are on this particular board. And this is an old board. This board's 6 months old. Again, it's ancient in drone years, but it does get the point across that everything I need to do, and you can see my instruments are there. These are standard instruments, so you can get a sense of what's going on from the pilot's perspective. If I want to see, there are sensors. So what we have now is a graph, and you can see the deflection coming from when I rotate or move my flight controller. Gyroscopes on top, accelerometers on the bottom. Whoops, where's my pointer? I have a pointer. There's my pointer. and I'm a thermographer, so my pointer is a radiometer. So this is the gyroscopes, accelerometer, and this is in g-forces, that's in degrees per second. So you can see pretty amazing what they've got in this little thing, and this was $20. So if we go back to my presentation, what's on here, all the information that's on here is going into something called the PID loop. Does anyone know what ever heard what PID before? Proportional integer derivative? Okay. Oh, you know what? I've got to sign back in again. All right. Let's see if I can talk and log onto the internet at the same time. So PID stands for proportional integer derivative, and it is the algorithm by which the drone knows its position in space and it knows where you want it to go. The best analogy I can give you, the simplest analogy, is the cruise control in your car. The cruise control in your car has been told by you to go at a certain speed, and it's measuring its speed, and it's measuring, how much power it's giving to the engine. When the speed changes, but the engine speed doesn't, it knows it's getting out of equilibrium. It's got to change the speed of the engine to achieve the equilibrium, which you've determined by telling it to go 55 miles an hour. So it knows how quickly it's slowing down, how much gas it's giving it, and how far or how quickly it's getting closer or further away from its intended equilibrium, that is 55 miles an hour. That's the PID loop in a nutshell. How fast where am I going, where do I want to go, and what are my inputs that I'm using to help me get there. We use the flight controller. It does things in exactly the same way. It just has more decisions to make. Am I left, right, forward, backward, climbing, decelerating? But it's the exact same principle as the cruise control in your car. Okay. So like I said, the flight controller has this algorithm that is comparing where it is in space, how quickly what's changing, and where its orientation is. And it makes its decisions based on, I want you to go this way. How do I change my orientation in space and the acceleration to my motors to get you there? So it's important to understand that much like the cruise control in your car, where you're not actually keeping your foot on the gas pedal, if you're flying a drone like this that has a flight controller, you're not actually deflecting the control surfaces. You're not accelerating the motors. You're telling the flight controller what you want it to achieve, what that new equilibrium is, and the flight controller makes a decision based on this PID loop how to get there. Any questions on that? Okay, so what's on the flight controller? USB socket to load firmware, output for battery voltage. I can power a buzzer. Losing a drone is a nightmare. So you can I've got on this one, I've got a buzzer wired into it using the output from the flight controller, and then I flip a switch on my transmitter if I can't find my drone. I also have it set to automatically do that if I lose a radio signal. Let's see, servo output, all the speed controllers I can handle up to, this particular flight controller can handle an octocopter, not just a quadcopter. That's up to 8 outputs, which means it can use up to 8 motors to help it with all its decisions about where to be in space and things like that. 3-axis accelerometer and gyroscope. I think, do I point to it? No, I don't point to it. Okay, they're all on here somewhere. I think the accelerometer and gyroscope, I don't remember which one. I've got it at the end of it. I think it's that guy there, the Avensense. Magnetic compass built in, 8 megabytes of flash memory, processor, and input for a barometer. All on this thing, and this is a big one. This is a big, clumsy, out-of-date one. There's also one on here. There's also a full flight controller on this thing. This is a full flying, camera-ready drone that I'm going to show you at the end of it. Okay, one thing, brushless motors. I think brushless motors should be of particular interest to the Computer Festival folks because it's the kind of motor that's in every floppy drive, every CD-ROM, every disk drive. I also think it bears an interesting resemblance to the radial engines of the old days. But what it's doing is it's got a computer, and it knows how quickly the axle's spinning, and it's pulsing to each of these coils to maintain the speed or to change its equilibrium. That is how fast we've told it to go in order to achieve the desired result, which is to read the drive or to spin the propeller. Brushless. It's a brushless motor. This, I don't know. I don't think it's a stepper motor. I think that's a predecessor to a brushless, isn't it? But I don't know. Okay, I know that I always called them brushless motor. I know it's neither AC nor DC, which is interesting. It's in between. But we could talk about it later if you'd like. You'd be interested to learn more. Okay, so this is specifically for this group because this is the autonomous vehicle themed Trenton Computer Festival. I wanted to spend a little bit of time talking about the sense and avoid functionality that's built into your average recreational drone. This comes off of the DJI website. This is the Phantom 4, and a quick demonstration of the So look closely as to how the drone is moving. This is what the pilot will see as they're going along. And they're intentionally flying it into objects. Never touch the controls during that time. So the primary challenge in the aviation world for sense and avoid is getting 3D vision from 2D sensors, and using multiple sensors to do that, and also for various conditions. The flight controller input, those accelerometers and gyroscopes I talked about before. In addition, this drone has ultrasonic ranging, so it has an ultrasonic altimeter pointed to the ground so it knows its height. It also uses something called photo flow. Actually, they might even be using video at this point. So it's constantly taking pictures of the ground and comparing this picture to the one before it. It determines, based on an algorithm, how it's moved and wiggles itself back into position to maintain a stationary reference to the photograph that it took before. That only works for about 30 meters to the ground and lower. After that, above that, it's exclusively GPS, but it's one of the primary sensing systems on the drone. So that's a visual camera, stereoscopic camera, and of course GPS. The most sort of heavy-handed avoidance technique of all is something called geofencing. Geofencing is simply programming into the drone, either by the manufacturer or by your ground control software, limits to where the drone can go. That is to say, you are not allowed to fly within a box defined by these GPS coordinates, and that's geofencing as the macro sense and avoid. Okay. This is usually the favorite part of the show. This is when I show some videos of drones crashing into things. That never gets old.
You ain't getting that one?
No, that one's not coming home. The audio is important here. Oof. Did you hear what he said?
No.
At least we got that on video. You're getting a theme here? Okay. Yeah, so people do dumb things with drones. All right, so what's in it for me? What am I as a layperson or potential pilot? What am I going to do with drones? You can take some awfully pretty pictures with it. I was a finalist in a photography contest for that one. My profession is thermography, so what I'm doing here is I'm looking for leaks in a roof, and I found them. It's these two splotches here, and I detect them there. So that was actually leaking onto a wheelchair access ramp, so we were really glad to find those. Come on, presentation. You can take pictures of your friends. You can get a kid really, really excited about math and science. If you're going fishing, you can do what only ESPN could do for you before, which is take a picture of you landing your own trophy fish from the back of the transom. I will say in advance, this is not a recreationally available drone. This is not a consumer-grade drone, but it is a real drone.
A drone that is strong enough to tow a server on a wakeboard.
Pretty powerful.
That's really powerful.
I can lift an anchor. Why can't I tow a surfer?
You can use as much energy as lifting an anchor. It doesn't necessarily mean lifting.
But the energy is there. The point is that the potential energy is there in this machine. And like I said, that's this one. That's not what they were. That's for cinematography. That'll carry like a 50-pound movie camera. I don't know what movie cameras weighs, but that's for movie cameras. All right, so what's next? One convention I heard, keynote speaker said millions of drones flying billions of missions. We're already performing recurring inspections of the Delaware Memorial Bridge. We've delivered pizza in New Zealand, vaccines in Rwanda. Tests are underway for deliveries in Nevada and other states. One point of clarification about that, the FAA has said specifically, we will consider exemptions for anything except drone deliveries. So the kinds of waivers that they're looking at, they have said specifically, you can bring us a lot of different things to look at as an exemption. Don't bother bringing us package delivery because it's not on the table. Not yet, no, not in this country. Now, in all fairness, 80% of all air traffic goes through the United States airspace system in the world. 80% of all traffic goes through the U.S. airspace system. We're a victim of our own success in that way, and so I understand if people are being a little extra careful before we take those kinds of steps. Sir?
Do the firemen use that heat thing when they're doing fires?
They do, but it has limited utility in that sense. They use them inside a building to look for hot spots, to know where the fire is coming from. It's really not good for finding people because in that sense the body's colder than the surrounding area. It also, contrary to what Hollywood would tell you, you can't see through walls with thermal imaging. It doesn't work that way.
The firemen were using some kind of sensors the other day.
Yes, they were. They had a tethered drone. This was the Bronx fire, right? Yeah, they were looking for hot spots so they would know where the roof was going to burn through, and that is a pretty common use. Pretty much every fire truck has a couple of thermal cameras on it for guys to take into a fire, and they're now exploring pretty seriously the applications for thermal imaging and drone imaging in general, from above. Agribusiness has used drones for years. It's nothing new to them. And they see new applications in pest detection, management, fertilization, that sort of thing. I've been asked to get involved with mosquito remediation, which I think is an interesting application for drones. There's small little areas, small pools of water, maybe on the other side of a canal. You either launch a boat and send somebody over to deal with it, or you launch a drone and just throw a little fertilizer on it, throw a little pesticide on it. Anyway, it's quite interesting to see what's happening there. Drone racing, it's not just a thing, it's a huge thing. Public service announcement tomorrow tonight is the premiere of the Drone Film Festival at NYU, and on Sunday is Drone Day at Liberty Science Center. If you want to see these things buzzing around, we'll have these out. I'll be there tomorrow volunteering, and you'll see a bunch of those racing inside and outside. And it kind of looks like this.
Is this Alex? Yeah. Oh, hi, Alex.
Okay, let's see if this works. So this is a new addition to the presentation. The folks at Alphabet have come up with a way for you to fly somebody else's drone. Anyone can, yeah, I take that. Up until they closed the beta, anyone could log in and do this. I think you have to get on a list now. But I also think it may be a little early. Yes, because it's all West Coast. But if I wanted to, if they were open, I could log in and fly a drone in Northern California, in the Southern California desert, in the Salton Sea, or at Ventura Beach. Cape Dot. Yeah, right. This is where geofencing comes in. So this is real. You can log in and do this. I've done it. It's amazing. I don't know that you. I think it's closed now. I think they've got too many people, but you can definitely get on the list. Question at the back?
Yeah, going back to the racing video.
Yeah.
The line of sight rules for operating a drone. Do you have to maintain line of sight for the entire flight of the drone?
Yeah, we fly within sight of the pilot at all times, and there's a spotter during the racing because they're FPV. So that's actually not allowed. You can't fly FPV without a spotter.
Okay. So the spotter, so maintained from the operator or the spotter.
Right. Exactly. Yeah. The rules say as long as someone can see the aircraft and that person is in communication with the pilot, you're good to go.
Okay.
Yep. Sure. Yeah. If you've got the eyesight for it, more power to you. I mean, in the model aviation world, you've got these big gliders with 15-foot wing, certainly 8-foot wingspans, and they can, they don't have the same limits that we do in terms of altitude operations. And so, as long as you can see it and feel that you can get your expensive, aircraft home safely, the more, go for it. But no, they don't specify a distance very intentionally. They say within line of sight, and then it's up to you as the pilot in command to determine what that is. I'm just about, yeah, go ahead.
I'm assuming the regulations right now are sort of like experimental mode, that they're going to be continuing
They are further than that. Actually, this is you can look up here if you want and see some of the differences. But what the rules that came out in August 107 were their first pass at final rules, in the sense that they had an intermediate period, the 333, between 2012 and 2016, when they were gathering information. This was the Modernization and Reform Act. When they were gathering information, they really intended for this release to be, not 100%, because it never is, but certainly, as firm as Part 61 was when they released it eons ago. This is the body of rules around around remote aviation.
The question is that, given the complexity of these things and a huge number of things that could possibly go wrong, how come it's not required to have a guard around the propeller for all these?
I don't know why it's not required, but we don't do it. I mean, first of all, if you go, it's really inefficient. It makes for a very poorly performing aircraft.
But that's a certain amount of that kind of overhead just about any mechanical device.
Why don't they have propellers around full-size aircraft? Guards around full-size aircraft. I mean, it's that kind of thing. Not to me, it's not. Okay, I don't know the ethical side of it. No one's even considering putting guards around all the propellers.
I think we saw on Mythbusters in 2019 where they tested drones against human analog, and most of the propellers are soft enough not to cause damage. They're more flexible.
That's cool.
But then they tried it on a commercial unit where the blades were carbon fiber and could cause damage.
Yeah.
That would be the reason.
I know that one of the drones that I have claims that their motor, the speed controller, can detect an obstruction and it stops. So I have not tested it, and I have no intentions of testing it. Yes, sir.
Is the status of delivery exactly like drones? You said that the FAA is not touching that.
Yeah.
What do you know about where is it going and what's going on?
So what I know about it is that the most expensive, one of the most expensive phases of package delivery is the last mile. So from an economic standpoint, everybody wants to solve that somehow. Some countries are very much in favor of supporting that. Some are less so. And even within the United States, Nevada, for example, seems to be very pro drone delivery, to the point where they are carving out air corridors and things like that for these kinds of tests. The technology, I would say, is very much there. There's nothing about the drone itself that precludes you from carrying a small package and dropping it off and coming back again. Airspace, bumping into things is going to be a consideration. I think pilfering is going to be a consideration. Stuff, I think it's going to be pretty easy to knock one of these things around in a more uncontrolled area. You're probably going to see, when it does happen, you're probably going to see some funny stories about how people gamed the system and got the goods delivered someplace else. I'm sure that's going to be there somehow. So the FAA considers within the body of regulations that I'm talking about, between 1/2 pound and 55 pounds. Yeah, up to 55 pounds is governed under these regulations. Bigger than that, and you're an experimental airplane. But I just want to say, yeah, okay. So let me just do this, and then I'll get you guys. So if you want to get into this, please learn and understand the rules, not just the FAA rules, but what's going on in your local community. The FAA does not get involved in issues of privacy. Local communities do. So you need to understand that there's multiple bodies of regulations that you need to understand and respect. In the words of Kevin Morris from the FAA, the media is waiting for something to happen. I fly big planes, I fly drones. I know that if one of my drones hits a commercial plane or gets ingested into an engine, that airplane is going to lose that engine and be in great jeopardy. This is much harder than a bird. These are metal parts, and these motors now are being made with titanium shafts. That's not the engine. The jet's going to lose that fight. So we need to be vigilant. I will say quite candidly that some people in this community, in the recreational side, have not been as respectful and really don't appreciate the risk that they're running. And I hope that we continue to educate them and make them better stewards of this hobby. If you're going to do it, buy a toy, something you can afford to lose. There is a drone in the river outside of my parents' house with an FAA registration number on it, and but I got a good recording of the geese that I chased away. Join the AMA and fly your join the AMA and your local flying club. Out where I am on the Jersey Shore, the Jersey Coast Sport Flyers is the local entity. Incidentally, if you join the AMA and you fly for fun, they have liability insurance that will cover you, which is a great comfort. If you're flying within the AMA regs, you're insured, and that's terrific. Get into FPV racing. If you want to make movies, a lot of people want to take pictures and make movies for their family. Get a post-production tool and learn it. There are free ones out there, but don't think that the raw footage that you get from your drone is going to be ready to do that, to do the recording of the wedding and things like that. It's just raw footage, and you're going to have to get good at telling the story and using the tools that storytelling requires, such as post-production tools. Sir, your question.
I got one for Christmas, and I was to join a club. That's one of my reasons to come here.
Oh, cool.
Would that be something that would teach me like how to run it and what the...
So in a couple of years, I would say that the AMA will be completely on board with drones, and there will be as many sort of people there to teach you and help you fly quads like this as there are to help you fly fixed wing and helicopters and those sorts of things. But it's not there right now. They're a little bit late to the drone party. If you want to get in with a community that really knows and understands drones, there's the Drone User Group. That's a national organization that's based in New York. And then there are meetup groups that are specifically focused on drones. The New York, New Jersey Drone User Group has 2,500 members. And they are a terrific community of people. They will meet for fun flies every Saturday. Yeah, so I would suggest the New Jersey Drone Meetup Group, and I can give you the information on that. Yeah, sure. Does everyone know Meetup? Meetup.com? It's a website where basically you go online in order to actually meet in face-to-face. Best idea ever. So Meetup.com has a drone user group, has multiple drone user groups, and the New Jersey Drone User Group is one of them. That's where I would start if you want to get into this from an amateur standpoint. And simulators. I had mixed results with simulators, but certainly something to consider. In the back. Sure. So again, do you want the AMA recreational answer, or do you want the commercial answer? Okay. Hi, you show what? I'll give you both because I have it right here. So the location requirements for flying for fun: 5 miles from an airport without prior notification, and air traffic control. So that's what the AMA says. For work, you have to be in Class G airspace.
So that means if I were to go to a local store to go to the vendor room and buy like a small toy drone, I could not fly it on this campus without contacting Trenton Airport?
That is correct, yes. Now, the process for doing that, you go on to the FAA. The process right now is not working very well because I'd like to do a job up in Connecticut, and it doesn't look like I'm going to get approval in time to do it. So really what I want to do is just call the local airport and say, hey guys, can I just go fly, please? But technically that's what I need to do. I need approval because I'm within 5 miles of that airport.
So I get the impression that that's a rule that gets violated pretty regularly by you go to Radio Shack, buy a toy drone, and fly it in your backyard.
My biggest competition is not other licensed remote pilots. It's people that are not licensed, but there's not a sense right now of, they're really kind of indifferent, I would say, to the licensing. Those of us that are in the business that want to respect and honor the rules are struggling because the rules keep us from taking some of those opportunities. Sir. I'm still working on that. Yeah, so it seems like inspections are going to be one of the big areas, and one of the reasons that I got a certification in thermography is because I realized that every kid with a camera drone was going to be a potential competitor, so I wanted that barrier to entry of some good technology. So that's why thermography was a good choice for me. And so what you do is you look at things. You look at things from altitude. What I'm specialized in looking at is things related to temperature, be that power lines with potential faults or roofs, either with a leak or with an insulation issue. Any low slope roof is a potential market for me. The other one that I find interesting is solar panels. Solar panels, when a cell on a solar panel is not working properly, the symptom is heat energy because the solar energy is not being converted to electricity. So on a day when the solar panels are operating at full capacity, you can take a picture, if you want, I can probably pull one up, you can take a picture of that array and see hotspots where they have defective cells. And I consider that a pretty lucrative market for me. There are 65,000 solar arrays installed in New Jersey. 85% of the capacity has come online in the past 5 years. I think that's it for the presentation. Simulator. Yes. So the floor is open for, oh, actually, one more thing to finish with. How am I on time? Am I over? I'm done. Okay, I'm done. I've got to let some other people on. Maybe we can pull over to the side, and if you want to come up and look at this stuff quickly as I pack up. I wanted to fly, but I'm out of time. I talk too much.